In this module, we will briefly discuss on how we can choose the value for k in KNN algorithm. So there might be lots of theories that you may find in the internet on how we can appropriately choose the k value in KNN, and normally in most cases the best value or the most used technique to determine the value of k is the square root of n, where n stands the number of samples in your training data set. So that's how you would generally assign the k value as. And so you know the importance of k value in the KNN is that the k value determines how well the model will generalize to the future data, and most of the time the user or the programmer tries to play around with the k value by varying the value that they would assign to the k in the KNN algorithm. And so they would try multiple values. Most of the time it's hit and trial, but the most effective or the most used technique to assign the value of k is the square root of n. So choosing the smaller values of k can be noisy and will have a higher influence on the result, while if you choose a larger value of k, it reduces the impact or variance caused by the noisy data. And there are both pros and cons of of having large k value and less k value, but I would recommend that uh, try to go with square root of n. And in the next slide over here, I have a data set, which is the breast cancer data set that I was able to pull from this site over here, which is University of I think it's Irvine, California State University. So that's where I got the data set from. And in this data set, I will sort of give you a demonstration of how the KNN algorithm can be used to to classify the cancer cells as malign or benign. So that's the kind of classification that we are going to do. And I have the data set over here. Sorry, I opened my R studio environment, so let me expand my R environment over here so that you can take a look at the R code. So as you can see, I already have the R code, and you don't really need to worry about this R code, because I'll be providing you with a copy of this code and as well as the data set. This is how the data set looks like, and I pulled it from this link over here, and I will provide a copy of this data set as well in the Canvas, so you don't really have to worry about much about this data. There are a number of fields in here. Don't ask me what this each field mean. You can go to this ICS website and take a look at the data dictionary. But let me quickly take you to the coding part over here. And this is like I demonstrated in the last week R code, you would first need to set the working directory. And this is what I have in here, because this is the directory where I have the data set, the breast cancer data set. And after I set in the working directory, I would import it. And this is sort of restructuring the data set. You don't really need to do this, but I did it, so I would recommend getting rid of the ID, the first identifier variable. We don't really need it, so you can keep it, but I prefer to drop it. And this is the I have done the recoding of the diagnosis variable over here. As if you look at this data set, then you have this variable diagnosis as malign, M for malign and B for benign. But I would like to put it a full form as benign and malignant. That's how I have it over here. And this is the I'm trying, and with this code I am trying to get the proportion. Let's run this code actually. And you know, there are 357 benign cases and 212 malign cases over here. And I would also like to get the summary. And yeah, this is pretty much what we did last week as well. So I will take you straight to the library that does the KNN. So please take a look at this data, this code over here. I will, you know, to make the most efficient use of time, I will skip it directly to this portion over here where we are creating the training and test data. So the first 469 rows, we are taking it as the training data, and the rest of the data, we are taking it as test data. And remember, training data is the data where you would implement your model, and you would check the efficacy of that model in the test data set. So we have it here as test data and training data set over here. And so that's that. And once we have done that, we would need to import this library called class. If you don't really have it, then you would need to install it. And install this class library, which if you don't really have it, then you can do it using the command install dot packages and put it as class if you don't really have it. But I have it installed, so I don't really need to do it. I only need to call the library here. And once you have done it, for the KNN algorithm, this is how you would do it. The direct syntax is KNN. Yeah, so it's pretty user friendly, the command and the syntax. So you would do it as KNN, and you would provide the training data set, train equals WBCD underscore train, because that's what you have, the training data set, and test as WBCD underscore test. And here, and you would assign the K as 21. So you have that. And to evaluate the models, you would need there's another library called gmodels, and call that library, and this is the cross tabulation that you have. And for this, I would need to run the entire code. Okay, I would need to restart, so I'm just going to hit cancel for now. But but this code runs, so whenever you get the chance to run the code, you should be able to run this code without any error. So the main part over here is creating the test data and the training data, and the rest of the code, if you if you look at the rest of the portion, where you would test, where you would evaluate the model performance, it is pretty much what we did last week. So that should not really be a problem. So what I would do is I would ask you guys to play with this data set, run the code, and I have commented each and every line of the code so that it's easy for you to understand. And in any case, if you have any issues or issues understanding the KNN concept, please feel free to reach out to me. And I have also added a couple of I think chi-square and other other statistical measure which we haven't really covered in this class, and which actually is not in the syllabus. So I would this is something that I put in so that you can take it yourself to understand the concept of chi-square, which is a statistical measure. And so this part over here is optional. You can run it or choose not to run it. That's completely up to you. So please play with the code, and if you have any issues, please feel free to reach out to me. I'll be more than glad to help you out. And yeah, so I would call it a wrap up for week 3, and I will see you in the next class.